Greetings, everyone. Happy Friday, and welcome to our webinar on deployment of models and apps in Julia. My name is Matt Bauman. I'm the Director of Applications Engineering at Julia Computing, and I've been working with the Julia language for a long time now, since about 2013. I discovered the language, and part of the reason why I discovered the language was because I had a huge intractable problem that I needed to solve, and my existing tool set was too slow, and I wanted to parallelize it, and I parallelized it as best I could on my local laptop. Well, now we at Julia Computing are building Julia Hub, the easiest and most straightforward way to build and deploy and get coding at scale. And that's what we'll be talking about today. I encourage you to leave questions in the chat box. We will, if I see a question in the chat box as I'm going through my presentation, I'll pause and answer it if it's relevant. Otherwise, I may just answer that at the end as well. So please be patient, but also please do enter your questions as you think of them in the chat box. Even if you're a little shy, if you're thinking it, probably someone else is too. So it's always great to have that interactivity in these demos, because that's precisely what I'll be doing today, is going through a few demo workflows of how this works with our live system. And so I can stop at any point and play around and answer questions. As you're aware, we'll of course be using the Julia programming language. It's a modern language, and if you're not familiar with it, I encourage you to check it out at julialang.org. You'll find all sorts of great materials, learning materials, teaching materials, community resources at that website. And I'm not going to spend too much time on the language itself today, because that's what we talked about last week. For those of you who are a part of the session last week, we talked a lot about the language itself, as well as interactive development on Julia Hub, the way in which you can launch IDEs with VS Code, notebooks with Pluto, and the ways in which we're making it easy and possible to do all your development directly in the cloud on larger machines than you have access to locally, potentially with GPUs attached to them. So if you're curious about more of that, check out our archived webinar from last week on interactive development at scale on Julia Hub. Today's webinar will be focusing on the other aspects of Julia Hub. In particular, we'll look at what large-scale distributed compute looks like. The ability that we kind of touched on last week of being able to launch big tasks on on-demand clusters, potentially with GPUs attached to it, and the ways in which those sorts of submitted jobs are reproducible and auditable. We'll be looking at some problems that process large amounts of data. And so for the first time today, I'll be digging into what we call data sets on Julia Hub. And it's built atop an awesome package in the open source ecosystem with some additional hooks in Julia Hub to make it even easier to use and deploy on cloud computers. Lastly, I'm going to go over what deployment looks like and how we're starting to build out interactive applications that you can build yourself or your organization can build and make available to you with Julia Hub Enterprise. So those are the main points that we'll be talking about today, and we'll be doing so largely through two big demos here. Excuse me just one second. Two big demos where we'll be talking about an illustrative finance example, where we will look at a historical analysis of currency exchange rates, where we are looking at 10 years of history of second level precision of exchange rates between a bunch of currencies. And we'll see how that looks. And all told, it ends up being a 40 gigabyte data set. We'll also look at what's called non-compartment analysis, which is a tool used, a very standard tool used by the pharmacology industry and pharmacometrics industry. And it's one of these sorts of jobs that really benefits from interactivity, really benefits from a GUI and allows one person to develop an application, deploy it to everybody, and allow them to run their code and develop standardized reports and such. And that's a deployed app by our partners at Puma's AI. And so we'll see what that looks like. And then I'll briefly touch on the ability for you to create your own apps. That's something that we're also working on and building out better tutorials and documentation on how you can do that on Julia Hub today. First, let's dig into this finance data set. What it is it's a history of the exchange rates live across the world, and they're constantly varying, right? And so one of the currency exchanges makes available historical exchange rates. And we have 40 gigabytes of this history dating back to 2009 through 2019. So 10 years of second level data on what these exchanges are doing. And of course, you can convert currencies through many paths, right? You can convert a euro to a dollar just directly, or you could potentially go through other currencies, potentially arbitraging inefficiencies in the market and looking at ways in which you can, develop trading strategies to exploit these sorts of things. And one of the best ways to do this is by looking at historical data to see what happens. So we'll build out this with the jump package, where we want to just go back in time and just kind of see, if we had $100 every five seconds or so to trade, how much profit could we make? And how inefficient is this market? And is there an opportunity to potentially try to do this at scale moving forward? Of course, this is a little bit of a toy example, but hopefully it shows you how we can work with a large data set, bigger than what we can fit in RAM on even medium-sized machines. 40 gigabytes is, you can spin up machines that could potentially hold that all in RAM, but it's efficient to be able to split it apart and have independent machines work on it separately. So that's what we'll look at. We'll go over to Julia Hub. You can just browse your way there. This is what the landing page looks like. If you're not signed in, you can sign in, attach a credit card to your account, and begin coding and spin up machines. So just like last week, we'll spin up a Julia IDE in the cloud as kind of our interface for this job. And so I've already done that here. We'll make this a little bit bigger. And so you can see that my launch button now has turned into a connect button. We can see the kinds of the choices that I would have if I hadn't already launched this job. It takes about 2 to 4 minutes to spin up a job on the first time you do it, because we're finding a machine in the cloud to give you launching it and building it for you. So you can start CPU jobs with potentially lots of memory, right? Or you can decide that you really want a GPU attached to it as well. And so, of course, the costs will vary depending upon how powerful of a machine you want. But this is one of the easiest ways to gain access to GPU programming from a laptop at home that doesn't have a beefy GPU attached to it. So I've already started up a CPU job here and can connect to it just by hitting this button, and it'll launch into VS Code like what we talked about yesterday. I'm going to browse over to the datasets demo folder that I've already pulled up and already have available to me here. And this is the script that we ran. Now, there's a few really cool things that are going on here. One is that we're using the datasets package to grab out the data directly from Julia Hub. Now, what does that mean in this context? Well, the answer there is that I have, within juliahub.com, gone in here, and we have this datasets tab under the run, because it's connected to the data that you want to process. And you can see datasets that I've now uploaded. And here is this historical TrueFX dataset. You can see that I've tagged it with some identifying information. It's just a whole slew of CSVs that I have access to, one for each pair of currencies for each month over the past 10 years. you can see that this data set is actually versioned. So if I changed it, that version would get noted. And the versions that I'm running against in my jobs is stored. So that way, everything that I do here is auditable. It is, reproducible. So that way I can go back and see what I did, check it out, and make sure that I can run it again, for example, or change something and try something new. So you can see here that we have this available to us. This is just using an S3 bucket, which of course costs a little bit of money here, about $1 a month to store my 40 gigabytes of data. And so it's not too big of a cost for me. But of course I could go in and edit these, delete them, download the latest data set and such, and we can play with it. So this is how I've set up Julia Hub now. So I've uploaded this data to this S3 bucket that Julia Hub knows about and has prioritized access to it. It's in the same data set. So there's no transfer costs, the bandwidth is high, and we can work with it very rapidly. So let's go back to my VS Code example here. Let's hide this, make this a little bit bigger. And you can see here, we can look at data set based upon its name. That historical true FX here is a data set that Julia Hub knows about. And at this, you can see here, this gives me out something that looks like a TOML file. You may be familiar with these TOML files from project.toml, right, which tracks your dependencies, the manifest.toml, which tracks all the installed versions of your applications. Maybe even you've played with artifacts.toml, which tracks deployed third-party libraries. This is what we call the data.toml, and it sets up a way in which we have access to this within Julia Hub. And there's actually a dedicated driver here that knows how to access this repository. This is private data to myself. Only if I'm logged in as myself do I see this. We're working on ways in which in the future you'll be able to flag these data sets as a potentially global or public accessible data to the whole world on juliahub.com, or potentially as an organization-based data set where within your organization, you'll be able to flag this. So that's not implemented yet, but that's really where we're charging towards, because that we see as a huge benefit, both to public data sets. When I gave my PlutoCon talk 2 weeks ago, folks were excited about this possibility of using data sets to potentially have Kaggle-like sorts of data available to you. You could also potentially have, public data sets like US Census or other census bureaus available to you that you can just use by name that are versioned and publicly available. And then of course, with Julia Hub Enterprise, we could have this available to just those folks that are authenticated through your organization. So that is kind of the basics of this. Now, where this really gets powerful is we just use standard Julia programming on this data set. And so I can open this data set as what's called the blob tree, which is kind of a funny way of talking about it. But what it does is it's saying, hey, this isn't just a single file, it's a directory of many files that are available to me. And so what this is doing is it's connecting to my S3 bucket, grabbing the lazy descriptions of each and every single one of my CSV files. Now I've also gzipped it because CSVs are plain text. You could also work with really any data format that Julia supports. In this case, the raw data came as CSVs, and so I just did a very simple transform to gzip it to reduce the file size by about 10-fold, which both reduces my storage costs and also increases my bandwidth as I process them. So now I can just iterate over these currency pairs within each month. And I set up my code here to do that. We just, let's see here, where are we? Here we go. So you can see I have my data set, which are the lists of all of these things. I split them based upon their names. I find a set of these, and I just have a set of these currency pairs. In this case, we'll just look at the possibilities between 5 pairs of currencies, between 4 pairs of currencies, between euros, dollars, pounds, and yen. And so we'll just look at this subset and use the file names themselves to figure out which files should be loaded and how we should distribute this computation across a large data set, right? And because these portions are lazily loaded, each computer that I run this on, each worker, doesn't need to download every single data set here. It can just work with the examples directly, just name the particular file that it wants to work with, and then open that directly, pass it in to csv.jl, right? If you look in here, you can see that we're just using a csv.read as a data frame with a gzip decompressor stream, right? And this is just using straightforward Julia syntax to, take out each file from our data set to grab, to load it, and we subset it based upon every 5 minutes or so to look in and see what arbitrage possibilities are available. Now, where this gets really fun is then we pass these data sets, right? So we look at each month independently, and we pass these to jump, where we have a set of constraints set up in terms of how we want to exchange these between each other, and the amount left over is going to be our profit. And so this is a standard integer programming example where we can use the GLPK interface, and I get a GLPK solver here that just does our, maximizes our profit within each time step. And of course, this is highly parallelizable, right? Because I can analyze each month independently. So when I go to submit this job to Julia Hub here, and connect back in, now I can set up a distributed job that has the capabilities that I want. And we'll go and see the job that I've already run. I just ran this yesterday, and we'll look at what happened here as we did this. But you can see that we can spin up an arbitrary number of nodes, define exactly how many cores we want within each node, how we want our Julia processes distributed across these, and each worker will just grab the data sets that it was passed by the distributed for loop here. We also have a few other little details of that kind of work with juliahub.com. And here specifically, we're going to store a little simple JSON dictionary of our outputs. And this we'll see in just 1 second of how that looks. But we're just tracking which dates we're looking at and how much profit we made. We then also write our profits for each time point to a CSV file, and we store that into a results file that we can then upload, and Julia Hub knows how to work. So once I've submitted this job, I'm not going to submit it here at live because I just did this yesterday. We can go back to our previous runs here, our previous runs table, and you can see some of the previous runs that I've ran here. And we can look and check out the details of exactly how this worked. So you can see that at 12:20 yesterday, I ran this file. It had 2 threads per core and 39 workers available to them, each with 8 gigs of memory. And we processed the entire data set over from May of 2009 to March of 2019. And we got a total profit. Now, you can see how long this job took. It took these 40 workers that we spun up 23 minutes and 30 seconds and exactly how much this cost. It's not a huge cost, right? And we can spin up more workers to distribute this out more ways. It's a very parallelizable task. And so you can play around with that. As I was developing this tutorial, this webinar, I actually tried a few other things here where I tried, let's go to this one here. I tried it at a smaller scale first, which is often a really awesome way of gaining a sense of the problem, gaining a sense of how this did. So I both ran it locally in my VS Code interactively. Once I was content with that, I submitted a small scale version of this that only processed 2 months of data on 10 workers. So it was a smaller job, cost me less, and allowed me to just make sure that everything was working the way I wanted it to. And of course, that was very cheap to do. And so this allowed me to play with it until I was satisfied. And of course, if you ever have a typo in your data set, well, it'll print out as a failure. you can go into the logs, test it out, see what went wrong, and load these logs and check them out. I'm not going to do that here, but you can gain a sense of what happens. So that is my data set. Now I can also just download that results file that I had. So all of those summary results, I could just click this results button here and it would download it to my local computer. I could also, though, just use this exact same interactive session as I had done to submit this job. Here again is that job from noon yesterday, and go into the actions and download the results locally to my computer, to this interactive instance. Now it temporarily saves them. I could move it to a directory that I wanted, or I could just copy the path, right? And then I can use CSV to read this path, right? So now I have a new path that I want to paste in here. I copied the path, and so I grab this, put it in quotes, because I'll read it as a data frame, and let's name it our profits here is our reading of this. And if I make my screen a little bit bigger so we can see what's happening, you can see that I ended up with a 7 million row data frame, right? And it just works nicely. We're dealing with a huge data set here, and we can play with this, see how much profit we were able to make in each 5-minute period based upon our jump arbitrage across these 4 currency pairs, or these 4 currencies, pairs between all 4 of them. So now, you might want to just plot this guy, right? So we can bring in the plotting environment and plot the timestamp. I'm going to decimate this and only plot 1,000 of them because we have 7 million rows here, right? This is actually a pretty big example of how we do this, and just take the cumulative sum of all of our profits as time has gone on and just plot this interactively using Julia. Pops up interactively here, and you can play with it and of course do all sorts of other analyses, not just on the total amount of profit, but the strategy, which currencies you're going through, if there are trends in the data set, right, depending upon how you set up the arbitrage example, and just what you're returning from each worker. That will determine the kinds of downstream analyses you can do. So this is running at scale with 40 gigabytes of data across 40 workers, allowing you to process huge data and do really cool Julia-specific things, right? The JUMP ecosystem is a really powerful and awesome ecosystem in Julia that allows you to do this, and it all, of course, composes nicely, just as we would hope with Julia. So that is my finance data set. I'll pause here. We got one question on the just on the webinar that we have. We'll be posting that. I guess it's not posted yet, but we'll post it to the juliacomputing.com/ let's see here. It goes under resources, webinars. So I guess we don't have this one up yet, but we'll be processing that and make that that webinar available to you all next week, as well as this very webinar too. Any questions on this large data set demo before I move on to my next demonstration? If not, we'll charge right on ahead. So the second portion of doing any sort of code, right? You want to make it available to users, yourself, others, right? It's not just about the code, it's about the results and what you can do and how you can communicate them and how you can enable others to run the analyses that you did, or potentially interface with them that way. So when you launch into juliahub.com, you'll see that we have 2 default applications, right? You can launch Pluto notebooks and you can launch Julia IDEs. These are interactive environments where you can do your development, right? They're geared towards development though, and not really towards display or real dashboards that you can publicize, right? We're working on Pluto to make it more full-featured and static renderings of notebooks and such, but really, you want to have a even more capable possibility of building out arbitrary websites and things like that. So we're adding into juliahub.com the ability to create your own applications in addition to the default applications that juliahub.com sets up for you. We'll have more documentation and tutorials on this possibility soon. But the idea is that you simply need to define a web application, a web-based application that potentially uses Dash or Genie or Stipple or any of these awesome Julia web programming tools to expose interactivity to the user with the capability of doing the Julia processing in the back end, the capability of connecting in to your Julia processes and connecting back into Julia Hub to potentially spawn off compute on clusters, because we're connected into this environment where we have access to huge amounts of compute at our fingertips relatively cheaply. So how do we extend this to whole organizations? Well, within Julia Hub Enterprise, we have this ability to add, in addition to the Julia IDE and the Pumas IDE, we have the ability to, or I'm sorry, in addition to Julia IDE and Pluto, which are the ones that are available by default on juliahub.com, within enterprise deployments, within companies, we can make available other applications. So in this example, we're partnering with Pumas AI, the awesome group that's building out huge tool sets in Julia for pharmacometricians and pharmacologists, where you can build these applications, and they're building dedicated applications that they're making available to entire organizations for interactive deployment. So that's where we'll go now, and we'll look at how this works in just one second. So I'm going to jump over to, let's see here. Here we have our Pumas AI organization for juliahub.com. And this is a specific organization, a specific instance of Julia Hub Enterprise, where this is just available to the folks at Pumas AI and others who work with us and work with Pumas AI to gain access here to these applications. But it's a great example of the sort of development that you can do and the sort of possibilities that are available to you. So Pumas AI is one of our launch partners with juliahub.com and one of our partners in building out these tool sets and really helping us develop the things that folks need to build these applications. So to demonstrate what a custom application looks like, I'm going to be doing the standard workflow called NCA. Now, I'm not a pharma person, that's not my background, but I can tell just a little bit about what this does. It's a very standard workflow for folks developing drugs to load in a standard interface. So we can launch and connect to this. I already have this up and running here. And when you connect to it, you have access to these projects. And this is, running Julia in the back end. It's giving me a nice interface here. And it's just a straightforward web application using Julia to drive this. So what makes this powerful is that there's a very standard CSV format for doing non-compartment analyses, or NCA, where you can add your own file just by dragging and dropping a CSV file here, or you can just decide to load an example data set here. And this is an example data set of what the diffusion of a diabetes drug looks like through the body after an IV infusion of 5,000 units. And so here is the observed concentration. You can see that I've loaded this and have all available to me directly. This is my CSV file here, right? Just displayed to me. I can look at it. My subject IDs and such are all available here. And then I can map columns. So, right, the CSV file has column names on it, and I can choose exactly which columns I want to have available to me. And now they even do the fun thing of looking at these strings, try to compare and guess which strings match the standard format, right? So we have our subject ID that is filled in for us, our time here, our concentration, and of course I could change this to however I want, right? And you can enter in your units of just, how this all works, and it'll use units to propagate its analyses. And of course, we're doing the amounts through IV. I could change this to the oral administered amount as well and see what that is. And potentially I could add a grouping columns, right? And for those of you who are familiar with Julia, you should be seeing some things here, right? This is just a data frame in the back end. And this just defines a group by operation. And so you could add a column here if we had, for example, demographics of the subjects. We could group by gender or group by other things or different dosage regimes, right? We could do a grouped analysis. In this case, we don't have any, but it's very easy to play with. We then hit next. And it brings up an analysis table for us where we can look in, let me zoom out just a little bit here, where we can look in at our observations for a given subject over time. So now this is the concentration of that drug in their bloodstream as time went on as we checked these things. And we're automatically fitting a best fit line on a subset of the data to maximize the R squared here to find which section of the data that you want to work with. This is a very standard analysis that folks do. And they'll go through and look at each subject, make sure that each subject is looking reasonable. And now what's cool about this is that you can go in and change what the system thought was the best answer. So I, as a scientist, can go in here and say, oh, you know what, this point really looks like it should be a part of this calculation. Let's include it as well. I have to note that and record that. And this application here creates a history of all the changes that I've done to this data set. And then I'd have to go back to the report and defend those choices that I made, give a reason for them. So I could even go into a particular individual and say, oh, this one looks really weird. It's an outlier. I could go in and potentially see if there was a reason that this looks strange, potentially even exclude it from any downstream analyses. Again, this action gets logged, and so I need to defend my choice in doing this in the subsequent report, but this is all available to you. And this is all just doing very straightforward, very simple linear fits, right? But this is a very standardized way of working with these sorts of data. So once I'm happy with the subjects that I'm using, I'm happy with the time points that I'm grabbing out, we can go in and create a report for the project. And this goes through, each subject calculates the results for it and allows you to directly play with it. What's really fun here is, while this is happening, it also generates a PDF for us to look at that has all of the things available to us that we need. So oh, there we go. So here you can see we're now complete on our report. It takes about 10 to 20 seconds to do. It's not bad. It doesn't need parallel compute. It doesn't need all those things, but what it needs is a nice interface for folks who aren't as competent with programming to work with and analyze the data themselves. So here you can see, some area under the curve that region in which the dosage is effective, right? The half-life, the maximum concentration across all of our subjects. And we get a report table out, right? Which has all of these things available to us for each subject, automatically created, automatically has the units propagated for us nicely. And then what's really cool is I can go here and export a PDF. You click this button and it downloads a PDF that's automatically generated that has all of these things available to you. You can go in. It's a 156-page report, which seems kind of crazy, but it has all of the figures that you want. It has all of the subject fits that you want. You can add your own annotations to these. And this is the kind of thing that you may end up submitting to the FDA, all annotated, all available, and a part of the drug development history for this drug. So this is really cool. It also has, the reproducibility information attached directly here. All of, the manifest is embedded inside this report. So anybody that has this report can go in here, reproduce it, and grab out exactly what we did. So this is an example of a deployed application that Pumas AI is developing and using directly, and is a really nice example of how you could work with and build out and start developing your own interfaces here, right? Where you have a Julia framework generating the HTML for you. And then as you analyze, as you generate these reports, it's just running Julia in a job in the backend that I've spun up and have access to. So that is running code on our Julia Hub web, yes, our webinar here. We can go back and now we can go in and wrap up here on our presentation. So as I said, these applications, you can develop them yourself. You work with them within your own account, and we'll have more details on that coming soon. But when you develop them, you might want to extend them and make them available to an entire organization. So that's precisely what we do with Julia Hub Enterprise, where we have the capability of, allowing administrators to flag particular applications as default for the entire team, and allows you to work with them directly. And you can then also, dig in and play with these things. So in this particular case, Julia is so fast that we didn't need the parallelism capabilities of Julia Hub. But what we needed was an interactive app that someone writes once and automates and simplifies this data exploration. You can see how, compared to some traditional tools, Julia's abundantly faster, where historically folks would try to parallelize these sorts of runs. We're on the factor of 10 to 100-fold faster. So you don't need to do that, and you can just do it all interactively. So that is Julia Hub. Thank you all for being a part of our Friday webinar series here. I hope this was entertaining and interesting to you all. I can stop here and we can answer any questions that you all had. So while just after I transitioned between the two data sets, we had a question from Julio about data sets and how specifically you move data sets to the cloud. And that's a great question, because it's something that I had to do, right, in order to get these 40 gigabytes available to us. So if I go back to my data sets tab here, you can potentially choose to do this interactively and do it just in your web browser, right? Where you can add a data set and you set up its name, you set up its tags, and you can choose a file from your file system to upload. This will just upload it from your local file system and does so through the browser, which leaves some things to be desired, right? When you're dependent upon a browser session to upload 40 gigabytes of data or more, we're actually working with a customer of ours to make available a 6 terabyte data set through these data sets. And you don't want to have a browser tab responsible for proxying 6 terabytes of data the whole way up to your system. So the way that you can do this, we actually have, of course, an API to do this instead of doing it through a web-based interface. This works really nicely for single file data sets, where instead of blob trees, or instead of having a directory of many files, they're just a single file that's on the order of 45 megabytes, right? That's far more reasonable to upload via a website. If you don't want to do that, let's see if I can pull up my history on how exactly I uploaded this data set to our Julia Hub instance. I did so using the datasets package. So I can just, of course, pull up Julia on the system where I had the data available to me. And we can go in and see the command that I ran to do this. Let's see, what would it be called? Oh yeah, of course. Oh no, why is it not in my history? Oh, it might be in my history here. Nope. Okay, I don't have it. The answer is to use Julia Hub, the Julia Hub client to upload this. Let's see here. There it is. Cool. So we have this Julia Hub client API that we'll be making publicly available very, very shortly. It's not publicly available yet. But what happens here is, I can upload a new data set with this client just through an API call here, name it, give it tags, give it a description. You can see that I actually typoed here. It's not through 2016, it's through 2019. So I could decide to build a new one. Now, what happens here is if I run this this example without specifying, so the first argument here is our data set name. The second argument is actually optional, and I could specify a path to data here, right? And choose exactly what path this would do, and this would upload it directly and manage everything for us there. I could also alternatively not specify this. And let's see, this is a little dangerous to do live because it will publish to my screen. If I don't have this available here, if I don't pass in this, it will publish to my screen the S3 credentials, the AWS credentials that are needed and the path and the bucket name and everything that you need to upload this directly from an AWS CLI or some other direct AWS mechanism. We're running on AWS and S3. And so this is kind of an escape hatch here where, for truly huge data sets, like a 6 terabyte one, for example, you may want to use a more direct method that kind of hacks into AWS's backend and reduces bandwidth and kind of just creates the transfer yourself. This will tell you those credentials. So I'm not going to do that because it would publish the private credentials to dump data into Julia Hub. But you can gain a sense of what that looks like. Actually, you know what? Here, let's just do it like this. Let's we can be fun here with it. So can go like this. Let me, I'll run it off screen and grab it. We can play with this and see if we can get it going. Shucks, I don't have the packages loaded for it. Never mind. That was a fun idea, but I think it's too tricky to do live here. So if you want to, there's another question now on how you could develop and share an app for anybody on the web, not necessarily a member of a team. That's precisely where we're going with our development. As of right now, we don't have that capability. What we do have is within our applications tab here, you have the ability to add an application, right? And this is just a path or a endpoint, a URL to some package, right? And so for now, one of the ways that you could publish this is by just having a get URL here to a public repository and instruct your users to add it independently to themselves. We're working on potential ways of declaring public applications and such, but that's farther down the road. The other way, of course, is through Julia Hub Enterprise, where we can directly support the organization itself, just like you saw within Puma's applications here, where there are multiple applications. Not only do we have VS Code here, but we also have VS Code with a fast precompiled Puma's instance. That system image is already generated for you, so you don't have to spin your wheels there. More improvements will be coming there shortly. That this is a temporary workaround for them right now, but that allows them to have access to that. So this is where we're going. We'll also be working on ways in which you can add authentication. So for example, if I go down to one of my applications here, you can go in and actually choose, I guess we don't have it enabled here. If I launch a Pluto session though, you can kind of see this. You can choose how this will authenticate, right? And it creates a public endpoint, but you have to authenticate to it. You can choose if it's only my account or any logged in Julia Hub user. This is particularly effective if you're within an enterprise organization and want to enable this application for everybody. That's another way of doing it. And yes, what happens here is when you launch this, all it's doing is it's setting up a Julia process that attaches to some port number, right? And so you can support any of the great Julia web frameworks like Dash.jl or Genie.jl or Stipple. Any of these frameworks are available to you. You just need to tell it which port to connect to, and Julia Hub will make that available. And so that's precisely how NCA works. So yes, this is all available. And then if you want to create a REST-based application, right? If you have an application that would be used as an API instead of a user-based, well, that's just as possible using HTTP.jl, setting up your paths, setting up your endpoints, and choosing how you respond to REST queries allows you to set these things up and make them available. Again, we'll continue iterating on these applications, allowing folks gaining more documentation. So we have public documentation at docs.juliahub.com that you can go and check out. And we'll be adding more and more tutorials here on creating, for example, applications. You can find, currently we have tutorials for data sets and the Cloud IDE, but we'll be adding an application tutorial here soon. So look for that in the future. Julio asks if there's an expected date for the Julia Hub clients.jl to be released. We currently have some proprietary code tangled in with it. We'll need to detangle that, but hopefully soon. I can't give you a hard deadline, unfortunately. I don't know, but it is something that we want to make available both publicly and within Julia Hub Enterprise. So with that, I want to thank you all for being a part of this Friday webinar series. Thank you everybody for being your questions and your attention has been appreciated. I hope you all have a great weekend, and check out juliahub.com. It really is a great way to do it. And within your first month, we give you $25 of free credits to play around with. And as you can see, that allows you to do some really cool things. So check it out, and hope to see you around. Please don't hesitate to contact us if you have any further questions on juliahub.com or Julia Hub Enterprise. We, of course, are always available and want to help you be successful in creating your Julia applications, and hopefully this gives you a sense of where we're going with that. Thanks, everyone. I will bring this to a close now. Have a great weekend.